In example 1, we're going to expand and simplify the following expressions. So I have a to the third times a to the fourth. So a to the third would be represented by a times a times a. So there's my a to the third. And then times a to the fourth. So a times a times a times a. On this, we'd say that a is the base of our exponential expression. And of course, 3 and 4 are exponents. When we multiply, we can see that if we consider it all together, we have 1, 2, 3, 4, 5, 6, 7. So a to the 7th. But expanding is not always the most practical way to go. So when we multiply expressions that have the same bases, notice that the 3 and the 4, we ended up with 7. So we added 3 and 4 and got 7. So that's going to lead to this product rule. If I'm multiplying two exponential expressions with the same base, I'm going to add the exponents. For b, I have a to the second raised to the third. So that's going to be to take a squared times itself 3 times. Then I'm going to take each of these a's and expand it. So a times a, another a times a, and then another a times a. And I get 1, 2, 3, 4, 5, 6, or a to the 6th. So we would call this a power to a power. So we have a power to a power. And when we expanded it, we can see that the exponents were multiplied. So that's going to lead to this power rule. A to the m raised to the n is going to be equal to a raised to the m times m. And then the division, I have a to the 5th, so I have the a's multiplied out, divided by a squared. Then we'll cancel those a's, and we're left with a to the 3rd power. And you can see that with the division, 5 subtract 2 is going to give me that 3, and that's going to lead to this quotient rule. A to the m divided by a to the n is equal to a raised to the m subtract n power. So I take the numerator exponent minus the denominator exponent. So let's use those rules. We have a product here. You can see that they all have the base of y. So that's going to be equal to my base, which is y. And then I'm going to add, this is an understood 1. So 1 plus 2 plus 4. And that would be y to the 7th power. My base here is a 2. So 2, and I'm going to add my exponents, 5 plus 3. And that's going to be 2 to the 8th power. Now, I should expand that, but I'm not real sure what that's going to be equal to. 2 to the 5th is 32, 64, 2 to the 6th, 128, 216, or 256. And then here we have a quotient rule. Again, you see the same base of 5. So this is going to be equal to 5. I'm going to take my exponent in the numerator, which is 8, and subtract the exponent in the denominator, 2. And that's going to be 5 to the 6th power, and I do not know what that is equal to. D, I have 20 divided by 4, which is 5. And then x, I'm going to use the ones with the same bases, 6 minus 5. So that's going to be 5x to the 1 power, which I won't write, because I could circle those answers. E, now on E, I'm going to do some multiplication. And again, I'm multiplying like bases. So I've got 3 times 5, which is 15. And then when I multiply my x's, I'm going to add 6, and then that understood 1. So 6 plus 1, so that's going to be 15, x to the 7th. Then F, these 18 will not divide into 24, but they will reduce by 6. So 6 will go into 24 4 times, and into 18, 3. So this is going to be equal to 4 thirds. And then for my A's, I will have A, and then I've got 14 minus 7. And for my B's, I'm going to have 6 minus 6. So this is going to be 4 thirds, A to the 7th, and B to the 0 power. Now we didn't mention that, but up here we have listed that if I have a 0 exponent, anything to the 0 power is 1. So when I get this b to the 0 power, it's equal to 1. And so I really just have 4/3 a to the 7th. And then finally, I have here, I have these last two problems. Use the quotient property to simplify x to the 3rd divided by x to the 5th. So the quotient property would say that I take my numerator exponent and subtract my denominator exponent, and I get x to the -2 power. And then on this right side, I'm going to expand it, so I get x to the 5th, which is x to the 3rd, which is x times x times x, over x to the 5th, which is x times x, x. We cancel, 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 and we're going to get 1 over x to the 2nd power. So what I'd like you to note, we're going to be working with these in the next video. X to the -2 is going to be equal to 1 over x squared. So if I have a negative exponent, it's going to move across the fraction bar, and that's stated right here.